statement or conditional statements again. But this time we're going to do multiple, which we kind of did a little bit already, and nested if statements. So a nested if statement is you have an if statement, and if the if statement becomes true, then underneath it you have another if statement. So it allows you to kind of bury deeper into a category as it fits the if statements going down. When you get into things like this, it does get a lot more complex, and you can get lost a little bit easier. So I often suggest, and when I'm doing this kind of coding I do myself, is I create a visual. And your visual can be on a napkin paper or whatever, a notebook, or you can use some kind of a program to map it out. But I do suggest you do it. There is an assignment in this topic that you have a lot of if statements involved, and I would strongly suggest you just write some kind of a visual before you go about trying to complete that assignment. So here's an example program that we're going to do. I already said that. And I just made myself a visual. I made it pretty because I'm sharing it up, but normally if I'm doing it myself, I'll just write it on a piece of paper. But here is the program that I'm writing. The program starts here at the top. It gathers some user input, and then each one of these diamonds is a decision point where it is an if and else situation. So I asked the user, as I did in the previous program you saw earlier, whether they want Star Trek or Star Wars. If they choose Star Trek, it follows this path to the left, and then I ask whether they prefer Picard or Kirk, and if they choose Picard, it displays something. If they choose Kirk, it displays something else, and if they put bad input, it displays a third thing. Same thing with the Star Wars side, Yoda or Vader, and display things. So everything in the end of this program ends up displaying something, but it ends up displaying a different thing based on the path that it takes. So not only does this visual allow me to understand my program a little bit easier even before I start writing it, it also gives me a very obvious visual of what my test cases are going to have to look like. I could even just straight up use this and put a checkbox next to each one of these saying, yes, I've tested this case, yes, I've tested this case, yes, I've tested this case. So it can be pretty powerful that way. So I've got my visual. I'm pretty happy with how I think this program is going to work. So I'm going to go ahead and write the program now. And here it is. And this is obviously not going to work in this view. So I'm going to exit out of this view so we can see it a little bit better. So this is the program that we just did on the display. I do want to note this is not the most efficient way to do this program. I've got some people in the class that have already taken other programming languages. The point of this is to demonstrate the material, so I'm kind of forcing this into the structure of nested if statements, although there are better ways to do this. But here we go. So first thing in my program I'm doing, I'm saying, do you want to choose Star Trek or Star Wars? And then they make a choice. And then now we get down to the if statements. And this is where the tabbing in Python is so important, because if you don't tab this correctly, they don't nest properly. So I've got this if statement that I'm saying if they said Star Trek, everything under this if statement happens only if this if statement turns out to be true. So if this if statement turns out to be false, it's going to go down to the elif path, and if that's true, it does that, or it's going to go down to the else path. The important thing here is if I had this off to the left, it's going to mess the whole program up, because I'm going to say if it's Star Trek, and then if that doesn't work, it's going to try this next if statement, even though this if statement is supposed to be nested under the first one. So I guess the short version of this is make sure your tabbing is correct when you're going through these things, because otherwise you're going to get very unexpected results. So continuing on. So if the choice is Star Trek, then I go underneath that and I ask the user again for input. I'm saying, okay, now tell me whether you want Picard or Kirk. And if they choose Picard, print this. If they choose Kirk, print that. If they make some kind of a stupid input, I can say a third thing. So my else path is kind of my catch-all for everything that doesn't fit the first two items. And then the program would end there. But if it didn't fit this first if path, then it will go down to the elif and do the same thing. I've got nested stuff underneath that. And then if the top level if statement is false, and the elif statement is also false, then it runs this else down here and prints this. So I'm going to go ahead and run this and just hit a few of the paths, so you don't have to watch me do this all day. But I'm going to just make a choice here. I'm going to say Star Wars. And then, so I chose Star Wars. That means it's up here. It realizes I chose this path. And now it's saying Yoda or Vader. And I'm going to say Vader, hit enter. And then because I chose Vader, that makes this path true. And so it prints, you don't know the power of the dark side. So it just steps through based on my input, the correct path to run through the program. Again, I can run it again. This time I can put in something stupid. And you can see that is illogical because it doesn't fit the if here, and it doesn't fit the elif here. So it ends up fitting the else. The other thing that's important here, if I run this again, and at the very beginning of the program, I type in Picard, it's not going to find this if statement because it doesn't qualify to check this if statement because it doesn't. This if statement is never true. So that's something else to make sure you understand. The nested if the if statements that are nested within other if statements don't get run unless the top level if statement is turned out to be true. So. Just a very simple nested program. This is not an uncommon thing to do. Typically, the stuff that you do within each one of the paths would probably be a little more useful if you're writing a real program instead of just printing to the screen. But this just demonstrates dealing with nested ifs and elses. So continuing on. Maybe. There we go. Yeah, well, this one isn't going to work any better in this view either. So let's go back to this other view again. Here's just another example because I love doing examples. This is a game. We're just going to play paper, rock, scissors. Again, this is not efficiently written. This is written in a way to exercise the new tools that we're using here, using ifs and else's and else ifs. You could, if you want to, spend some time trying to think of a way to make this more efficient. As we get more tools in our tool belt later on, other ways of making this more efficient will become more apparent, but you may be able to figure some of this out yourself now, as well as less error prone because there are holes here that you could fall into if you get certain scenarios. So just to step through this thing, playing paper, rock, scissors, I'm going to import the random module. Random module is really good for just getting random things. You can use it in a lot of different ways. We don't get into a lot of depth about how it works in this course, but you can go out and read the documentation on it. It's a pretty commonly used module. But anyway, so I've got options here. I'm creating a list called options, and under that, in that list, I have 3 items: paper, rock, and scissors. And then I am creating a variable called my selection, and I'm using that random module to say, give me a random choice from my list options. So this variable, my selection, is either going to have paper, rock, or scissors in it. I don't know which at this point. It just randomly chose one and assigned it to that variable. And then I'm going to ask the user of the program, hey, what do you want to choose? Because you're playing against me. And it's saying, please choose paper, rock, or scissors. And then the person types in whatever one they want. And then I'm going to say, your selection is this, and my selection is this. So I'm telling them, hey, here's what we ended up with. And now we go through the path to determine who won. And so I've got an if statement here that says, if your selection.lower is not in options, meaning you put something goofy like lizard or Spock, instead of paper, rock, or scissors, I'm just going to say you messed up and end the program. But if if you put in one of those 3 options, we continue down. And in the elif, I'm saying if my selection, meaning the randomly selected choice, is the same as your selection, then we just say, hey, it's a tie and the game ends. So if we don't hit the first path, we don't hit the second path, then we go to the third one here, where I'm saying if my selection is paper and your selection is rock, then I win, but otherwise you win. And if that path isn't the chosen one, I say if my selection's rock and yours is scissors, then I say I win because rock beats scissors. Otherwise, you win because if you didn't pick scissors, you had to have picked paper, which means paper beats rock. So that means you win. And then this last path, same thing. If I pick scissors and you pick paper, I say, hey, I win because scissors beats paper. But if you didn't pick paper, you had to have picked rock. Otherwise, we wouldn't have arrived at this else statement. Then you win. So that's essentially how the program works. If I run this, I just say choose. I'll choose, as the user, choose rock. And it says your selection is rock, my selection is rock, so it's a tie. And that's really all it does. So you can run it over and over again, see if you can beat this highly sophisticated paper, rock, scissors program. Apparently we're going to keep tying, so you never get to see any of the paths. If you are mocking, this might be a situation where you try to figure out how to put this into a function and mock it, so you could definitely get expected outputs. So that's just a fun little game. I'm going to continue and do just one more of those here because I like the games. I think it makes it more interesting to learn this stuff. This one's just a number guessing game. So again, I am importing random because I need to have that to be able to get a random number. And then I'm creating a variable called mySecretNumber, and I'm assigning it a random integer. So I'm using random.randint, and it's between 1 and 101 non-inclusive. So if you looked at the documentation for this random module under random int, it is inclusive of the first number and it is non-inclusive of the last number. So I'm essentially saying, give me a number that is from 1 to 100. So that's what that's doing there. And then I'm assigning your guess as 0. And I'm doing something here that we can't do yet because we learn while loops next week. But I wanted to point out the if statements here because that's what we're doing this week. So don't worry too much about the while loop. You'll learn about that soon enough. But I'm saying while your guess is not equal to my secret number, I'm going to say give me a number or guess a number. And if your guess is lower than my number, then I'm going to tell you my number is bigger than that. If your guess is bigger than my number, then I'm going to say, hey, my number is smaller than that. And then otherwise, I'm going to say, hey, you figured out my number, which was this. So it's going to keep going around and around and around this program until we get the output that the user matches what we want them to get, and then the program ends. So if I say guess the number, let's say 45, it's bigger than that, I do 75, 55. Hey, I figured out the number was 55, and then the program ends. So that's just a fun little game. I played this with my 5-year-old for quite a while when I wrote this. Whenever I wrote this a while back, and he just really thought it was fantastic that we could build something like that. And then he wanted me to go ahead and build really advanced stuff, and I'm like, no, that's not how it works. It's easy to build things like this, but not easy to build, Super Mario Brothers. So anyway, but yeah, so that's just a little thing, and it shows you how to use, again, that these ifs and elifs and else statements can be useful, and then stacking them with while loops, which we'll learn about next week, can even make them more useful. Okay, so continuing on, I want to do a little bit about unit testing for rounding issues. So in topic 3, you're going to have a somewhat difficult assignment, and one of the things that people often run into with that assignment is the unit testing around it. You get into sometimes some scenarios where you run into rounding issues, and this is something that is a weirdness about binary math. And numbers that should come out evenly don't always come out quite evenly. So you might expect that, let's say you did 4 divided by 8, and you expect it to be 0.5, but for whatever reason it's 0.49999999996 because of some weirdness about binary math. I couldn't find a good example to actually show you showing it happen. I've run into it in the past. I probably should have written down the exact scenario that it happened, but you may run into it as you're doing these assignments. So I want to make sure you have this new tool in your tool belt, because if you tried to take that 4.9 or 0.4999999 and compare it to 0.5, which you expect the output to be, and say these two equal, it's going to say no because they're not quite equal. So what you can use is you can use assert almost equal do this. So here I've just got this goofy function I made. It literally just returns 1 divided by 3. We know 1 divided by 3 is an irrational number. It just goes 0.3333 forever and ever. So I just wanted to create a function so I could call it for a unit test. Oop, I gotta actually run that. Sorry. Where are you at? There we go. One slide up. Why is this acting so silly? There we go. So now I'm on it. Okay, so now I can go ahead and test that. So again, we've done this before. Import unit test. I'm creating a class and I'm testing rounding. And then this is the part that's new. Under my function where I'm doing my test, I'm saying self-assert almost equal junk function, which is the thing I just created. I want to compare whether this is almost equal to this, and then I'm going to say round to 4 places. So this is where you can determine how detailed you want to get on your checks. And when it says places, that means the number of places after the decimal place. So what this will do is it will take the output from my function, which we know is 0.333333, and it will round that to 4 decimal places. It will take the item I'm trying to compare it to, round it to 4 decimal places, and then do the comparison. So I will find that these two, in fact, pass the test because they will be equal up to 4 decimal places. And you can see it ran the test and worked without an issue. So you may want to do that for your tests this week instead of trying to use assert equal, or you can attempt to do assert equal and then see if you run into the issue, but just be aware that it might be an unexpected rounding issue that you're running into. Okay.